Thanks for joining us for the Future Food Show. This is your host, Alex Shirazi, and we're really excited to have Aniekan on the show today. Welcome to the show.
Thanks very much, Alex. Thanks for having me on.
Usually, I will ask before we start recording, tell me about the pronunciation, just so we get it right, so it's always correct. But I wanted to ask you, what is the best way to pronounce your name?
Oh, thanks for that. You were very close, actually. So my first name is pronounced Aniekan, and the surname is Esenam. And as you can tell, it's not a typical European name. I was born in Nigeria, in West Africa, and my name actually comes from the Cameroon side. So you can imagine we had artificial barriers and boundaries put in Nigeria. So I come from a tribe that actually is Cameroonian, but I fall into a small part of Nigeria. So in terms of ancestry, my name is Nigerian. In terms of modern usage, most people have called me Anakin ever since I can remember, which is interesting because the most famous Anakin they probably know is obviously Skywalker or Darth Vader.
And so, or the only Anakin I know.
Exactly. And so from age 7 onwards, that's the only way that people have been able to remember who I am, by always making that link to Anakin Skywalker. And so sometimes it doesn't matter when I'm at work or go to a conference or an event or any kind of presentation, when I meet people, it's after fumbling with my name for 10 seconds and they realize, is it pronounced like Anakin, like in Skywalker? And so I usually say yes, if that makes it easy for you.
Well, and that's also a kind of a cool character to reference.
Absolutely. Amazing that after all these years, we're talking about 42 years or so, since Star Wars first came out. It doesn't matter what generation of people I speak to, they immediately make that connection. And it makes meeting people easy.
Yeah, no, that's cool. And it's a good icebreaker too.
Absolutely.
So, and actually, we might have talked about this on our prep call, which was quite a while ago. But okay, so you mentioned you are from Nigerian heritage.
That's correct.
There's this Nigerian chicken dish with like a spicy red sauce. Do you know what I'm talking about? And as I'm asking you, I think we might have talked about it before. And you might have said there's lots of dishes like that. But I wanted to ask you.
Exactly. There's lots of dishes like that. Most people just think about sticking to jollof rice, but with chicken. But we have so many different dishes that could be a description of. Nigeria itself, with its 180, 190 million people, is divided into, if I remember correctly, 42 different language groups. And each of those is a mini culture in itself. So therefore, they all have their own take on a standard dish.
Wow. Okay. I'm just thinking about all these amazing types of dishes and different types of flavors that can come from that. That's very cool.
Exactly. Now, flavor is one of the things that is very common in Nigeria, but in Africa generally, which obviously is the use of flavoring of spices, both local spices and obviously imported spices. But we're definitely a spice kingdom.
I like that, Spice Kingdom. So I want to, and thanks for telling us a little bit about the background of your name, but tell us about your background, your professional and academic background.
Absolutely. Okay, so I'm one of those unusual people in that I studied mathematics at university. And one of the things that I also notice when I speak to an American is that, I wasn't good at math, or I hate math. and people raise their eyebrows when I said I studied mathematics. But I've been fascinated by logic, by problem solving. And I had a bit of a penchant for using maths and the way maths is applied across different industries in terms of just building that logical approach to problem solving. And so after earning my degree in mathematics, I started my career at IBM, of all places, in the software industry, where I worked initially as a developer, optimizing neural network solutions. So nowadays it's AI, it's large language models. But in those days, I worked on very small language models. And these were models mainly used in oil and gas and finance industries. In oil and gas, just to give us an example, these were used for reservoir modeling to determine potential before sinking in large costs into drilling. And in finance, it was used, obviously, to support trading as well as things like foreign exchange in terms of developing forecasts for where the market might be going and also where the currencies are going. From there, I transitioned into roles that combine technical expertise with business strategy. I worked as a consultant, helping companies in life sciences bring products to market. And this taught me the complexities of product development, regulatory approval, and commercialization. I'm going to skip a lot of the early career and jump into more relevant and more recent career. So, for example, from 2015 to 2017, I led a digital transformation at Syngenta, which is a crop chemicals and seeds company. And I was developing what they termed a digital agronomy platform. So this integrated AI, computer vision, satellite and drone imagery, near infrared data and sensing. And this enabled Syngenta to help their customers transform agriculture into a highly efficient data-driven industry. The platform also enabled more precise seeding and targeted pesticide use and applications. So as you can imagine, it helped the customers save costs. And for the environment, it helped in not having any wasted seeds and definitely by not overspraying chemicals, which, as you can imagine, leach into waterways. So this is where I started getting interested in the broader agriculture and food industry, but also sustainability. So this, again, this platform, as I emphasize, helped in sparing water channels of harmful chemicals. And that's how it got me thinking about the broader food and agriculture industry and the application of technologies in that area.
Cool.
And
And I just wanted to jump in and ask. So
yeah,
you're currently based in Switzerland. Were a lot of these projects also in Switzerland?
globally, Syngenta is based in Switzerland and I was based here, but the platform was developed in the US and the farmers, the initial farmers that we brought on board were all from Iowa and Kansas. And then we then spread north to Canada and then south to Brazil. I left the company at that stage and here I am at Hamilton.
Cool, very cool. Okay, and at Hamilton, like you said, you're mentioned you're based in Switzerland,
That's correct. Yeah.
and but tell us about a little bit about Hamilton as a company. Where
Mhm.
are their kind of headquarters, and what are some of the primary products that Hamilton focuses on?
I'd be glad to. Thank you for that. So Hamilton Bonaduz AG is that's an interesting question. It's a Swiss-based company founded in 1940 in the 1940s by Clark Hamilton, so you can tell he's an American. And we have headquarters in Reno, Nevada, and Bonaduz. So we basically have focus of different industries within the USA and a focus on a global basis out of Switzerland. But the family, the Hamilton family, are still our major owners and shareholders, and we share two global headquarters, so Reno and Bonaduz.
Ah, cool. Okay,
Yeah.
and Bonaduz is in Switzerland. How far is that from Zurich? Just to put a pin on the
Oh,
map.
that's a question that I feel embarrassed I can't answer.
Oh no.
It's oh my God, I think it's about 150 kilometers from
Okay.
Zurich. It's basically in Canton Graubünden. We're in the mountains. We're into the
Oh,
ski
cool.
area. Yeah.
Wow.
So people holiday here for skiing. And one of the great things about being here at Hamilton is the view from the window. We
Oh,
see the
wow.
mountains, and a lot of my colleagues go hiking and skiing in season, after work. So that's one of the beauties of being here. I live in the Zurich area, so I'm a long distance commuter. So I didn't get the chance to really enjoy it so much, but it's a great place to be. Every day feels like being on vacation when you come here.
Wow, that is cool. So how long have you been at Hamilton, and tell us about the department that you're focused on, the projects that you're working on there.
Okay, that's fair. Thanks very much. I've been at Hamilton since February 2023. And one of the things I didn't mention is that so the company is structured as being four different entities or four different business units. So we have storage solutions. So these are mainly used within biopharma and pharmaceutical industries for, as you can imagine, storage of things like vaccines and chemicals. Medical. Medical came to its fore during the COVID because medical makes ventilators and respiratory systems. Process analytics, that's the division that I work in, where we develop sensors and measurement devices which are critical for monitoring biopharma and industrial processes, and in our case, novel foods. And then robotics, which is for automated liquid handling workstations and if you imagine this is pipetting robots, which were essential during the pandemic for things like sampling lots and lots of, well, sampling lots and lots of, or testing lots and lots of samples in a very short time for COVID and so forth. So those are the four business units. And I work within process analytics. I'm allied to the marketing function. Although, as I mentioned, I wear a triple crown. I wear three hats within the company. So one of the hats is looking for external growth opportunities, so whether that's partnerships and M&A, joint venturing. Another hat is driving the strategic cycle within the company, within process analytics. And then the third hat, for which, while we're talking today, is developing Hamilton's opportunity and approach to the novel foods industry. There's a lot of terminology out there, whether it's alt proteins, cultivated meats, etc. But we're sticking to novel foods, and because this accurately describes the two focus areas for us, which is basically either cell-based, so cultivated food, cultivated seafood, etc., cultivated meat, or which is basically a microbial-based, and which is essentially precision fermentation. So this for us is novel foods. That's the part within which I focus on.
Okay, cool. And on this show, usually we talk pretty high level. We don't get too deep into the sciences, but maybe I think it might be interesting. Maybe what we can do is we can walk through a very high level or basic bioprocess,
Mhm.
and then first, and then add the layer of kind of where Hamilton comes in on top of that. Do you think that might be interesting to do?
I think that'd be a great idea, actually.
Okay.
It creates a context for those who'll be listening to this podcast to understand what we do and how, let's say, a cultivated meat or fish goes from a petri dish, from a cell, to a structured product. Yeah, I can do that.
Okay, cool. So let's say we have a sample of a cell and we have it in a petri dish. I guess the next stage from doing any petri dish testing would then be in a very small bioreactor vessel, right?
Absolutely, absolutely. So let's basically try and create the picture and then walk through from left to right. So we
I
have a
love it.
sample. Yeah, we have a sample that's it's in a petri dish. It's not really. It will be in some kind of a dish-based container in a ventilated system that is biosealed. But let's just say this in a petri dish. And the first thing would be to create that biopsy. That biopsy will be placed in some kind of sterile saline solution to prevent contamination. And then that cell, in some form or other, in some small size or other, will seed a small flask to start with some growth media. And after some time, the first however many, 1,000, 10,000 cells will grow in that flask and that growth media, and then that will then be transferred into your smaller scale bioreactors. We're talking about anywhere from 500 mil to maybe 1 or 2 liters, and that will then have some fresh media and growth factors applied. Where our sensors come in is that our sensors would have been used, first of all, our pH and conductivity sensors would have been used in media prep. For example, the pH sensor would have been used to test the water that's being put into the media prep, and the conductivity sensor would have been used against the different kind of salts, amino acids, etc., the other nutrients that are going to be mixed together to create your growth media and growth factors. So we've already used sensors to make sure that the environment that the cells are going to be grown in is already appropriate. So then we then add that to the bioreactor. So now essentially we're cooking. We're now cooking new technology. As and over a number of days or weeks, as your cells are growing, we will have a pH sensor in the bioreactor. We will have a dissolved oxygen sensor in the bioreactor. We'll have, if there's enough ports, maybe a CO2, dissolved CO2 sensor, and hopefully, definitely we'll have our cell density sensors. So to talk through each one of these, so our pH is essentially checking the environment that those cells are being seeded into to make sure that's appropriate for their growing and their metabolic requirements. The O2, the dissolved oxygen sensor, just to make sure that enough oxygen is going in, just as we humans need oxygen for living, the cells are living organisms. They'll need oxygen also. So the dissolved CO2 helps in tracking and monitoring the amount of oxygen that's going into the medium for the cells for growth. The CO2 is as we also perspire and I'm going to say perspire, and we also emit CO2. And these can be dangerous to cells. So again, we also monitor the CO2 levels and also directly look at cell growth rates, cell growth densities using the cell density sensors. So all of these is making sure that we can measure and monitor the metabolic health of the cells as they're growing, because cultivated meat at the end of the day is really the cells. The amount of cells you grow is really where the value is. So therefore, cell density is looking at the actual cell yield, essentially, and then the CO2 and O2 in balance is making sure is looking at is making sure that the cells themselves are actually alive.
Okay, wow, cool. And I have been sketching out a very small doodles. Maybe I'll share those with this. But that was a very clear picture. A couple questions that come up.
Yeah,
Okay, so the sensors that you use to mix the media, and that media can actually be used even in the early petri dish stages, right?
correct. Yeah,
So
yeah.
and those sensors, is that a different sensor, like a physical form or hardware, than the one that goes into the bioreactor?
The sensors themselves, I'll answer that in two ways. The sensors, or at least the sensing mechanism, is the same, but the sensors will vary in size and also will be varied depending on whether it's a reusable sensor that basically is put into the bioreactor or the mixer for the medium that is being prepared, or if we're using something like single use, which is another approach, then the sensors could be either as a probe that goes into the bioreactor, or it could be a patch that's on the bag that the actual content will reside in. And so therefore the physical element might vary, but the sensing approach is the same.
Okay, very cool. And so some of these sensors are part of single use containers, right?
That's correct. Yeah.
Okay, so then
Yeah.
so for 500 milliliter, we might have a single use, like you said. Actually, at 500 millimeters, would you use you wouldn't use a patch, would you?
No, that'd be too small.
That'd be
That'd be
too
too small.
small. Yeah,
Yeah.
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 But I don't know if these are the kind of systems that you integrate to, but I have seen like these like plastic, very small vessels, like on I guess Sartorius amber or something, and
Yeah.
then the sensors are at the bottom. Do you have things like that?
Yes, we do. Yeah, yes, we
Okay.
do. Yeah, yeah. With an amber size, in single use, with a bag inside it, will probably have a sensor at the bottom. It could be, and then you then probably have other sensors which are probes. Single use. So, for example, the pH single use is an actual physical probe that comes into one of the ports, whereas, for example, cell density is a patch.
Okay.
Yeah,
Okay. And
yeah.
then once you get to, let's say, 5 liters or greater, then are all of these sensors probes, or are there still some
You have
other
a choice.
types?
You have a choice, because at 5 liters and above, then there's a large enough vessel that you could actually put physical probes in, or you might run a single use system depending on what your drivers are, specific drivers, and your approach within your bioprocess within your lab. But we would have a choice. I tend not to see so many single use at that scale, although the industry is moving more towards that. Initially, it was very much reusable probes at that kind of small scale, and then single use might be in, I don't know, 50 liters to 1,000 liters in pilot scale, or initial scale ups, and then. But again, it depends on whether for your application, you want to go down the single use route, which has some advantages, as you can imagine, or you want to go down the stainless steel large bioreactor route. So again, companies make a decision, and then the choice of sensor is based on that decision.
Oh, interesting. Okay.
Yeah.
So it seems like there are different types of solutions for every system. So let's say we're at a 50-liter single use, then you can choose, in that scenario, you can choose either, let me rephrase that, a 50-liter single use vessel, right? Those plastic ones. And you could use either a probe into the bioreactor system, or you could use single use sensors as well.
That's correct. I'll give an example since my focus. I've seen lots of different approaches. by different companies within the biopharma, but speaking from the customers that I have or we Hamilton have and that I have seen their systems within cultivated meat and cultivated chocolate. I'll give you those two examples. The cultivated chocolate example at 50 liters, they're now more or less trying out their scaling. And to de risk contamination, and also to have very short batch to batch times, they used single use. And the
Okay.
example from the meat company, on the other hand, they used sensors and they used a stainless steel tank.
Ah, okay. Stainless steel. Okay.
Yeah. And
At
so
the at 50 liters for both of those examples.
exactly.
Yeah.
Yeah.
Okay. And what's the probe size? Is that a standardized kind of diameter size that goes into the
In
vessels?
in terms of probe length, it seems to be fairly standard. Yeah, the longer length goes into benchtop bioreactors in R&D, and the shorter length goes into larger vessels in pilot and scale up. So you tend to find whether it's 400 millimeter for 40 millimeter, 220, 120 millimeters. So therefore, the smaller it gets or the shorter it gets, then the larger the system.
Okay, and the Hamilton sensors, regardless of type, can fit into a variety of bioreactor systems. So is
That's
that
correct. That's correct. Yeah.
okay?
So we always say that we can work with companies all the way from upstream in R&D with with a longer bioreactor longer sensor lengths, all the way down to downstream when they're using shorter sensor lengths. At the same time, don't forget that we also work across different industries where there are liquid-based solutions where the environment is important. So whether it's something like, say, wastewater treatment in power generation or even in breweries and beverage production. So we have to have lots of different lengths and the capability of creating different lengths based on whatever environment the customer needs.
I see. Okay, so you could create, especially in larger scale applications, you could create or have custom sizes.
That's correct. Yeah. And so that's one of our key strengths, and that is that I've seen meter long sensors, and I've also seen, as I described, 10, 12 millimeter sensors.
Oh wow. Okay.
Yeah.
Okay. Cool. Wow. So this thank you for that. That's very helpful. I think that for me at least, and hopefully those listening, it puts it into a lot more of a perspective on exactly how to analyze your bioprocess. And what I wanted to ask is, what is the typical? So from a readout standpoint,
Mhm.
where do you is it like a Hamilton software, or what kind of software do you use to review the data?
Okay, that's actually a good question. This the that we have own software that provides data for the bioscientists to use, but a lot of the times our solutions will be integrated into some kind of a bioprocess control and monitoring systems that the actual lab is using. So therefore, they don't have to run separate systems by using Hamilton products. They'll integrate into those systems using industry integration techniques.
Okay, cool.
Yeah,
Very cool. Yeah.
and then the data is then available within a dashboard of data that your bioprocess scientist is reviewing, and with that he can then make decisions about things like feeding strategies, harvesting, etc.
Okay, cool. Yeah, and continuously optimize from there.
Absolutely,
Yeah.
absolutely,
And
yeah.
I guess in many cases is currently running multiple experiments batches at once to get all these different data points.
Yeah, absolutely. That's one of the things that I see a lot more now. Referring back to the comment you made about small scale bioreactors, we are seeing now multiple parallel batches being run using these smaller systems. And so, therefore, one of the key things now is the bioprocess scientists being inundated with a deluge of data from each of these batches, each of these runs, to try and find the optimal for scaling up.
Do you know of emerging AI technologies that are looking at some of this data and helping scientists make decisions?
I wouldn't say emerging AI technology because they're all still using essentially machine learning to help in two key areas: Anal- optimizing their bioprocess, but with the focus towards cost reduction. And so, therefore, looking at things like nutrients, the nutrient uptake. And because obviously, as people always ask, well, what are the impediments to the novel foods, but specifically cultivated foods industry? And we talk about things like the cost of media and the cost of nutrients. Then it's how to optimize the nutrients by basically analyzing and modeling intake for based on optimal conditions. And so therefore those specific elements that go into your media can then be reduced. And similar with nutrient analysis and modeling for things like glucose and lactates.
Okay, great. And those costs are more associated to like the media inputs for the cocktail, so to speak. But if we're first of all, is that correct?
I'm sorry?
What you just referenced is more
Yes.
of costs for the media, right?
Absolutely.
Right.
Absolutely. Yeah.
And what I wanted to ask is with the Hamilton sensors, the approaches, there's a wide variety of approaches. Are there certain things that are, let's say you're setting up a more basic system, it would be cheaper to go this route versus that route? And I guess initially I would think, oh, if you go single use, maybe it's cheaper, but that could actually be more expensive in the long run. Is that right?
It has advantages. It has advantages, and initially, in the short, with smaller systems, it appears to be more expensive to go down the single use route. But in the long run, probably not, because you look at the overall cost. One of the costs is obviously the potential cost of contamination if you have to throw away a batch, and this is very much reduced by going single use. There's the time to the next run, which is in terms of downtime, cleaning of your bioreactor, and again, the potential inherent risks that the cleaning process might have left some residue of contamination, potential contamination. So therefore, companies make the decision that at a certain size, it actually is more cost effective to go single use because of reduced risk of contamination, because of reduced downtime from batch to batch.
Interesting. Okay. Yeah.
Yeah.
No, that definitely makes sense. Wow. Okay. Cool. And pH sensors, conductivity sensors, dissolved oxygen sensors, CO2 level, cell
And
density. Is there
correct. Yeah.
anything we're missing?
No, that's what we have currently. But as with many other companies, we also have new innovations that are in the pipelines, and we're always launching new products into the market, new solutions. Watch this space.
So broadly speaking, and I know I think you mentioned robotics as one of the Hamilton areas, but so broadly speaking, what kind of cool new innovations have you seen in biotech in general? And it doesn't have to be related to your current work. Anything you've seen that is exciting?
I think that within our industry, some of the kind of innovations around, in a sense, small liquid volume analysis, I find quite interesting because now you're no longer having to provide large or liters or milliliters of solution for analysis. Now, essentially, you're talking about droplet size. And this is where our robotics business is actually now pioneering the ability to work with droplet sizes, even very small droplet sizes, very much not visible to the naked eye, and actually do testing and analysis on there. That I think is actually quite interesting because now that companies are moving more and more towards smaller flasks, smaller bioreactors for analysis, the ability to get much more value and analytics out of a droplet is where the industry is going. And Hamilton is very much, again, at the forefront of that.
Wow. Okay, that's cool. And it seems like that'll help move things much faster and just help in a
Absolutely.
variety of ways. Yeah.
Absolutely. Absolutely. Yeah, you no longer have to wait or oversample by basically losing produce, because one of the things we said at the beginning was that within, say, cultivated meat or but novel foods in general, including also precision fermentation, the produce, the actual cells that grow is the produce. And so you don't want, and if you're doing things like testing for a variety of different elements, then what you don't want to do is sampling and losing produce. So therefore, the ability to make use of droplet size is actually going to be key.
Interesting. Cool. And if there is a novel food company out there that is in the R&D stages and beyond, what is the best way for them to get in touch with Hamilton?
They can come onto our Hamilton website. We're also present at most novel foods, alternative proteins conferences, both in the USA and across Europe. And they can also contact me directly and link in with me, and I'll be happy to make the new contacts. We also have a cultivated food group on LinkedIn, and so therefore there's a variety of ways that they can contact Hamilton.
Cool. And I also saw there was a cultivated food production website, a section on the website. So we'll
That's
link that in the
correct.
show notes as well.
Thank you very much, Alex.
Cool. This has been really exciting chatting with you. I have one last question,
Yes.
and I was wondering if you have any last insights or thoughts or anything like that for our listeners today.
Well, not really an insight, but it's more of a thought, which is the excitement. One of the reasons why I got into this industry, which is the expectation that potentially by 2040, we could be eating 60% of our meat consumption coming from novel foods. That excites me. And knowing that Hamilton's products will be in the bioreactors and production systems that's going to bring that into the world.
You had me at chocolate. I love that. Aniekan, thank you so much for being a guest on the show.
Alex, thank you very much for inviting me.
This is your host, Alex, and we look forward to seeing you on our next episode.